So you want to get into microcontrollers, but don't know where to start. I'm going to lay out your hardware needs in this video. Let's first talk about actual microcontrollers. So they come in different variety and different fashions that you can choose from different manufacturers. You have ST Micro right here. You have Texas Instrument microcontroller right here. You have a Raspberry Pi. You can actually use this bad boy as a microcontroller. You have the ESP Nano. This guy right here has Bluetooth built into it. It's actually the cheapest one out of them all. We got the Mega. This bad boy here is based upon the AT Mega platform. And we have AT Mega ripoffs right here. You know, these cheap little guys, they still do the job. And then finally, you have the original Arduino Uno, which is by far the most popular one out of them all. It's also been around the most as well. So out of all these, which one would I choose? I wouldn't choose this one for you guys, unless you're really into it. I wouldn't choose this one either. So these are development board made by Texas Instrument and S3 Micro. And so you can develop on here without actually getting the board. So you get this, you build code and everything. The problem with these aren't necessarily built upon the Arduino platform and are probably going to need quite a bit more experience. So I wouldn't get these until you master this guy. So the Raspberry Pi, I like this guy. It can do everything this can do and even more. It's a built-in computer. You can play Minecraft and run a controller at the same time. It's a little bit more involved than just the AT Mega, different platform. You can figure it out. I wouldn't start there either. So that leaves us with all these. All these guys are based upon the Arduino platform. So what the Arduino platform is it's a programming platform built by Arduino, which allows you to upload sketches, write software, and load it on the controller and run it on your controller. Well-known used tool with plenty of libraries everywhere. There's a lot of source documentation, lots of help. There's sample scripts inside the tool, which all you have to do is click on it, load, and you're done, and it runs the program. So out of all these boards, I would actually go with either the old style Arduino Uno R3, which comes with a removable microcontroller. The thing is, once you get into this hobby, you're going to blow a few of these. And having this be able to be moved out and replaced is actually kind of nice. But for cost impact, this guy at the time of us speaking is $22. And it comes with Bluetooth. So this one is based upon the ESP32 microcontroller, which is a Bluetooth module that just has the same capabilities. This is based upon the AT Mega ESP32. These other boards are just knockoffs of the Arduino. This one says it's a AT Mega. Do I believe it? I don't know. Lots of stuff coming over from China. You just don't know where it came from. But I would start with either one of these. This, because it's been around the longest. There's a massive library. You're not going to have any issues with this. Or this one, it's cost effective. It already has Bluetooth. But if you get this, you want to implement Bluetooth, eventually you'll have to move one of these in there. So you got to take all this into account when you make your selection. But I think if you get this board, or if you get this board, you're going to be fine. I haven't used this board a lot. I've used this a lot. I've broken a lot of these. All right, so we have this red line. This is all one connected strip. This is made for power. You have this negative right here, this blue part, that's made for ground. So you apply your voltage here and your ground here. So this whole strip has continuity up and down. Now you go into these inner parts, the continuity, I mean it's the same plane, it's the same reference, goes from here to here. And then you have the split down the middle, and then you have the same thing on the other side. And then you have another power strip. This time it's on this side, and then you have your ground right here. When you get your power, you'll want to plug in the high voltage right here and ground right there. What this thing allows you to do is you can take modules like this Bluetooth module right here, and you can slide it right there or slide it wherever. Now you can apply jumper wires to go where you want. That bridges us into the next part you'll need, and that is wires. Got a whole bunch of these. First type of wire is these jumper wires. These easily get slotted into your breadboard like this. So you can make connections from one point to another. When you do this, when you use these, you get a nice looking circuit board that looks like this. So I have made this little board with optic couplers and LEDs and resistors. And I can do this because of these jumpers. I can put the power, I can put the ground where I want, and I can bridge connect these wherever I want just by using these. I definitely get a set of these. Second thing I would get is these wires. These are all these bridge wires. You have a female and female. You have male to males. And you have females to males. What this allows you to do is take these wires, plug it into a pin. Now you can jumper it right there. Makes it all easy. All these tools made it to make your job easy when you line all these up. Now what's next? My favorite tool, the one that I've used a little too much, would be the multimeter. These come in a variety of different styles and different price points. This is a $30 one you can get off of Amazon. This is a $10 one you can get down at your Walmart. You know, they both do the same thing. One might be nicer than the other. They have $100 ones right there, and each one has its own little function. But for doing what we're doing, this $10 one will probably suit most of your needs. I don't use the $10 one. I use this one, or I use a Fluke. I like those, and those work better. For this purposes, if you need to get a multimeter, all you can get is this $10 one. You're going to be fine. And so up to this point, we haven't done anything that allows the operation of the microcontroller. So I would add resistors. All different types of resistors. You can get packs online that has various different types of resistors. You'll need different types, and you'll definitely use this. So the thing with microcontrollers is this isn't designed really to drive loads. It's designed to connect to chips like this, and this drives your load. So this is a motor controller. You get your signal input from here. So this isn't made to drive loads. This is one of your first projects, though, that you'll end up doing is driving an LED. So this is one of those exceptions to where you can use a pin for here. So it's usually 20 milliamps or below that you can use to draw current from this thing. That's why you have these resistors. You connect the resistors up through this pin to ground and you're good. If you take one of these pins, turn it on, connect it straight to ground, well, this is dead. That easy. How do you know how to use one of these? It's Ohm's law. So voltage divided by resistance is your current. So you have 5 volts. You have 1K resistance. You get what? 10 milliamps? Look that up. Ohm's law. Majority of the stuff that you can do on your microcontroller, that's the biggest thing. Just know your Ohm's law and you should be good. Now, there's another factor you got to learn. And that's your power. So what's power? It's your voltage times your resistance is your power. If you have 5 volts and 10 milliamps, how much power is that? Next thing I would get is actually a pack of LEDs. These guys right here. So these are simple to use. You have an anode, and you have a cathode. It only goes one way. So the anode is usually the long one. Your power's got to go in there, and your cathode needs to go to ground. So you add a series resistance in with this, and you apply a voltage to it, it'll power up. So I definitely get a set of these LEDs. That's just to get started. You know, you get a microcontroller, you start practicing. First thing you want to do is learn how to turn on and off your inputs. To know if those turn on or off, you can either use a digital multimeter or you can use a visual reference like this. There's also online kits that you can get that'll do everything that you need to do. They're usually pretty cheap. Some of them come with a microcontroller, and then they'll come with an assortment of electronics. Just kind of like this guy. This got more electronics in there that you'll probably ever need. Though I probably end up running out of wires eventually. Here's another one right here. This is actually a Raspberry Pi kit, but it comes with a lot of stuff you can use on Arduino. Another good one right here is this sensor kit. Right here. So this has 37 different types of sensors. You just start using these one by one, figuring out how they work. That'll go good too. Get a few motor drivers like this. And then now let's talk about power. For these guys, so you'll need a source. You need a source of voltage, and it'll probably have to be above 5. Unless you're using the Nano, then you can do 5. But then a 9-volt power supply right here. So this is a 9-volt battery. It has a barrel jack right here. You plug it into your microcontroller. You get a 9-volt battery. You have 9 volts going right in there. Right here. So you'll need an external power supply. One last thing I tell you have to get is the potentiometer. So this will teach you how to do your analog read functions in the microcontroller. Once we get there, you'll learn easily. Other things, you have switches like this guy. It's an on-off switch. So you apply a voltage to the input, and the output runs to the microcontroller. You push the button, the microcontroller knows when it turns on. And you release the button, the microcontroller knows when it turns off. Now, don't forget to add your resistor, but you can do the opposite. You can source the power from the microcontroller through the button, and then when you click the button, when it sources to ground, the microcontroller knows. Still got to use your resistor. It'll blow your board. So I think that's it for the absolute essentials. And then as you go along, you're going to know what you need. Other things that I would recommend, this will be how far along you are in your microcontroller journey, you'll eventually want an oscilloscope like this guy right here. So with this, I can read any waveform that's coming out of the Arduino at any time, and I know exactly what it is doing. So I can make adjustments based upon what I see here on my circuitry. This is nice to have. I wouldn't get it until you're really deep down into the weeds, but this is a nice to have. Second thing is a nice to have is so you can use this to run your test circuits and apply a higher voltage than you usually would. So yeah, that's what I would start off with. Yeah, that's where I would start off with. So I'll release more videos. Oh yeah, software. Software is the fun one. So you got to know a little bit about software. There's plenty of sketches online that can show you and walk you through. I'll walk you through a few of them too. But in summary, you'll need to get a microcontroller. You'll need to power your microcontroller with a source. So you'll need a USB to program your microcontroller. You'll need the Arduino script tool. Let's see. LEDs, resistors. You'll eventually need capacitors. Yeah, so there's assortments of stuff. You can get most of this stuff in a single kit that comes with everything, and you'll be fine that way. And a breadboard. I have 20 of these things lying around. I don't know why I have 20 of these, but I have 20 of these lying around. I'll release a video next going through the simple functions on your microcontroller. So if you enjoyed the content, please hit a like and subscribe. I hope you have a wonderful day.